In most air and hydraulic fluid power circuits, valves are used to control the direction, rate, and pressure in fluid lines. Control valves for these functions can be purchased with either manual or solenoid actuators. In a manually actuated valve, the internal cylinder is shifted by hand using a lever, push button, plunger, or other manual actuating device. By contrast, valves with a solenoid actuator respond to an electrical signal for shifting. With electrical control, machine cycles can be set up for automatic sequencing, and operator control can be exercised from a remote location. Solenoid valves are said to be either direct or pilot operated. A direct operated valve is shown here. A pilot-operated valve has a pilot and bleed orifice and utilizes line pressure for operation. This is a pilot-operated relief valve. When the solenoid is energized, the core opens the pilot orifice and relieves pressure from the top of the valve piston or diaphragm to the outlet side of the valve. This results in an unbalanced pressure, lifting the piston or diaphragm off the main orifice. When the solenoid is de-energized, the pilot orifice is closed and full line pressure is applied to the top of the piston or diaphragm, closing the valve. Most directly operated valves also come in pilot-operated versions and are designated by a triangular graphic symbol. A single solenoid valve has one solenoid to assist in valve operation. The valve spool shifts when the solenoid receives an electrical signal and is energized. The valve will remain shifted as long as electrical current is applied to the solenoid. Once the electrical current is removed and the solenoid is de-energized, the valve returns to its normal position by spring force. Fluid circuits designed to use single solenoid valves must maintain electrical current in order to keep the valve in its shifted position. Double solenoid valves have two solenoids, typically mounted on opposite ends of the valve body. This type of two-position double solenoid valve does not have a spring return. When the first solenoid is energized, the valve spool shifts into the first position. Even if the first solenoid is de-energized, the spool remains shifted. This is because there is no spring to return the spool to its original position. Energizing the second solenoid will send the valve to the second position. Even if the second solenoid is de-energized, the valve will remain shifted until the first solenoid is re-energized. Since there is nothing holding the valve in the shifted position other than friction, these types of valves should be mounted horizontally to avoid self-shift due to excessive airflow or vibration. If both solenoids are energized at the same time, the solenoids will work against each other and may cause the spool to become stuck, electrical burnout of the solenoid, or an overload of inrush current to the circuit, any of which will cause severe damage to the system or valve. A three-position valve has a spring-centered neutral position for its internal spool. Because of the centering springs, it's necessary to hold current on one solenoid or the other to keep the spool in one of its side positions. When each solenoid is energized, the valve shifts to the appropriate position. Anytime both solenoids are de-energized, the valve spool will spring to center and stop the fluid flow. Therefore, a three-position valve requires a maintained electrical signal for its operation. As before, energizing both solenoids at once may cause damage to the valve or to the system. To prevent this from occurring, electrical circuits should be designed to make it impossible to have current on both solenoids at the same time. Solenoid valves are used in both hydraulic fluid and air systems to control direction on cylinders from deceleration or speed control and pump unloading or pressure control. The physical appearance of each component will vary greatly depending on brand, size, and type, so care should be taken to reference the appropriate manufacturer's guidance when choosing a solenoid valve. Computer systems used within the industrial sector are connected by networks known generally as field bus. Field bus systems are a way to connect computers and instruments to a single network in a manufacturing plant and allow for real-time control and monitoring. Field bus industrial networks can be broken down into 4 levels, each with increasing levels of complexity. The most basic level is the sensor bus networks. Sensor bus networks are the least complex of networks developed for industrial application. In these networks, multiple basic field devices like limit switches or level optical sensors are connected to one network cable. The sensor bus network is also capable of transmitting output signals from the controller over one cable to indicator lamps, alarms, or other actuator devices. The next increasingly complex level of industrial field bus networking is the device bus network. The device bus network is similar in function to the sensor bus network, but works on a larger scale, connecting many sensors and actuators together. The device bus network also connects equipment to variable speed drives and motor control centers that allow for control of individual elements in the network. Moving up the pyramid, the next increasing complex level of field bus networking is the control bus network. Control bus networks are the most advanced networks used on the factory floor, and data communication happens at a high level. PLCs, or programmable logic controllers, are connected to each other alongside HMIs, or human interface panels, to allow for complete configuration and control of every instrument on the network. Smart instruments capable of performing complex operations can also be connected at this network level. For instance, there might be a smart instrument that measures wear and tear on a valve. When the wear reaches a dangerous level, it will signal the controller that the valve needs to be replaced. The enterprise or information level network in a company connects all computers and departments together. It is the most overarching and complex of all the various network levels. This level of networking is primarily computer-driven, which allows for data collection, data monitoring, file transfers, and email exchange on a large scale. The various levels of interconnected field bus networking help to keep industry functioning smoothly and successfully.